Okay, grade 9 practice test on rational numbers. The first question is a true or false question. It says negative 1 and 3/4, and then it has that little symbol there, and then it says negative 1 and 7, so 1.72. Remember, as you read it from left to right, if the number you read, if the symbol, the greater than less than symbol, is eating what you said, you must read that symbol as is greater than. So when I read this, I read negative 1 and 3/4 is greater than negative 1.72. So for these questions, I said you can't use a calculator, and the reason why is this is pretty easy to change to the same format, so you can change them either both to decimals or both to fractions. This is easier. And remember, on a number line, the farther a number is, so this would be right here, and this would be right there. The farther a number is away from 0, the smaller it is. So therefore, this is smaller than this, and therefore the answer to the first question in your test is false. Now, if you note the work I showed that I converted both to the same format, either both to fractions or both to decimals. I drew a number line to show the proximity to 0. I showed that one number is farther from 0 and therefore is smaller. But there's a lot of information in there that you should probably be trying to internalize as ways that you can show your work. So on your paper, hopefully you made a note of something like that. Question 2 says negative 1 and 2/3 is a fraction between negative 1.6 and negative 1.5. So if I think about this, there's negative 1.4, negative 1.5, negative 1.6, negative 1.7. And negative 1 and 2/3, well, 2/3 is one of those fractions that you should know by now. It's decimal 6 repeating. So that's the same thing as negative 1 decimal 6 repeating, or approximately equal to negative 1 decimal 666. So when I was to put that somewhere, I would put it somewhere between right around here on a number line. And is that between negative 1.6 and 1.5? The answer is no. So your answer for that is false. Question number 3. Now this question, somebody said to me, you said there wouldn't be any multiplication questions that we have to do without a calculator. And the answer is you don't need it. Because if I look at this, I don't care what number that is, and I don't care what number it is. But when I add negatives to negatives, I know that this answer is going to be negative something. And I don't even care what the answer is. It's going to be negative something. And when I multiply a negative by a negative, I know that this is going to be a positive something. A positive something. It doesn't matter about the numbers. I just know that from looking at the question. So is it possible that a negative something is bigger than a positive something? The answer is no, it's not possible. So therefore, it's false. Okay? When you multiply two negatives together, you will always get a positive product. And when you add two negatives together, you will always get a negative sum. The third question, a good estimation for this question will be negative 14. So again, does not require a calculator. So if I take this question here, and let's bring it down here. How will I do this? Well, I'll change the numbers to non-decimal. So negative 5, take away 9. Now that's a question that should not require a calculator. That is negative 14. But if I keep flip change, because if you're one of those people who has a hard time subtracting, 5 negatives plus 9 negatives is still 14 negatives. So the answer for question 4 is true. That is a good estimation. The next question says reorder these 4 numbers in ascending order. So I'll take these here. Now remember, when you have rational numbers, you can either change them all to fraction form with common denominators or decimal form. I think we all agreed in chapter 2.1 that it's easiest to change them to decimals. So in this particular one, I can think of it as a division statement, but I can also think of it as a mixed or as an improper fraction. How many 50s are there in 120? There's 2 and 20 50ths. That would be that, which would be, I guess, negative 2 decimal 4, 0 if I wanted, because I can make it into 40 hundredths or 4 tenths. But that's negative 2 decimal 4 as a decimal. This is negative 2 decimal 333-ish, repeating to infinity. This is negative 2 decimal 35 terminating decimal. And this is negative 2 decimal 666 repeating to infinity, because 2/3 is decimal 6 repeating. So now that I have them all in decimal form, I have to then think about what is the farthest from 0. So if I have negative 3 here, and we'll put negative, let's just make this negative 2 here. Negative 2 there, negative 3 there. Negative 2.333, this one, is going to be the closest to 0, and therefore this is our largest number. Then we're going to go, that's number, I'll just put number 1 above there. That's negative 2.3 repeating. Then we're going to go here with negative 2.35. That's the next largest number. Then we're going to go in, the next one would be negative 2.4. And then we're going to go negative 2.6 repeating. Remember, it says in ascending order, which means from smallest to largest. So our smallest number is this one. So I'm going to write it as the smallest number. Right? That's the farthest from 0. Our next smallest number is this one, which is negative 120 over 50. Then our next smallest is this one, which is negative 2.35. And finally, our largest is negative 2.3 repeating. So there they are in ascending order, from smallest to largest. Please try not to reverse them and go in descending order. The next question says use greater than, less than, or equal to for these following questions. So the next, by the way, what question is this? 6. Okay, question 6. So the first question says negative 3/5 is less than, greater than, or equal to negative 0.6 repeating. So some of you had a hard time changing 3/5 to a decimal without a calculator. Remember, if you can make an equivalent fraction where the denominator of the equivalent fraction is 10, 100, or 1,000, you have the ability to read it and write it. So 3/5 is equal to 6/10. So therefore, since 3/5 is equal to 6/10, and 6/10 is decimal 6, changing that to a decimal is not too hard. And this one, since it's a repeating decimal, I want to kind of look at it like that, just to kind of see more place value. Remember, the closer a number is to 0, the greater it is. So that one there is closer to 0, and therefore negative 3/5 is greater than negative 0.6 repeating. Your next one, negative 2.135, and negative 2 1/10 will be negative 2 1/10. The closer it is to 0, the greater it is. Therefore, negative 2.1 is greater because it's closer to 0. And finally, 18 over 5. Well, how many 5s are there in 18? There's 3. How many left over? 3/5. So changing that division, or that question there, that improper fraction to a mixed, you would get negative 3 3/5. Or, as a decimal, negative 3, actually as an equivalent fraction with a base 10 denominator, negative 3 6/10. So negative 3.6 is the decimal version of that particular fraction. Negative 3.5 is still over here. The closer it is to 0 when it's negative, the bigger it is. Therefore, negative 3.5 is greater than negative 18/5. And there's the, so change the improper to mixed, change the mixed without a calculator to a mixed fraction with a base 10 denominator, read the fraction as negative 3 6/10, and wrote it as a decimal using place value knowledge. Question number 7, I think, right? What two fractions in lowest terms with 8 as a denominator are between 0 and negative 1? Well, let's just pretend that it's 0 and 1. Let's just use that. Let's forget it's negative. Doesn't matter if it's negative. So if I think about fractions that are greater than 0 but less than 1, I could put this, I can put this, I can put this, I can put this, I can put this, etc., all the way up to this. I guess there's only one I missed with 6/8. Any of those fractions are fractions that are between 0 and 1, because that's what fractions represent, part of a number. So now that we go back to this original one and say, what are numbers that are between 0 and negative 1, all we have to do is slap a negative symbol on there, and all of those answers, all 7 of them, are fractions that have 8 as a denominator and are between 0 and negative 1. A lot easier than you thought. This is not question 5, but follow along and you're good. So here we have 0.8 or 8/10 plus negative 2.1. Now, if we estimated, we'd say 1 plus -2, and our estimation would be -1. How did I do that? Well, if I think about a picture, and I said, well, what do I have more of, negatives or positives? Well, I have more negatives. How many more negatives? We'd be taking my negatives, subtract my positives to figure out I have one more negative than I do positive, right? I would actually subtract the one I have more of from the one I have less of to figure out how many more I had. Well, that same holds true over here. I have more negatives, and how many more negatives I have than positives, it's a subtraction. I want to figure out how many more negatives do I have. So I got to borrow. I get 3. I get 1. I have 1.3 more negatives than I do positives, and therefore that is your answer. Pretty close to my estimation of -1. Your next question is a subtraction question, and I know it's a lot of you like to do subtraction without having to use the keep, flip, change, but I'm a big fan of it, especially with these types of questions. So if you keep, flip, change, because you know it's going to allow you to keep to get the same answer, they're going to be equivalent in terms of their value. I can say, what do I have more of, negatives or positives? Well, in this case, I have more negatives. So I have this many negatives and this many positives. How many more negatives do I have? I have 1.5 more negatives than I do positives. So my answer is -1.5. And if I estimated, -3 take away -1 would have been -2, which is pretty close to my estimation of -1.5. -5.5 times 3. I did say I wasn't going to give you multiplication, but this is not so hard. 5 times 5 is 15. 0.5 times 3 is 1.5. You put them together, you get 16.5. A negative multiplied by a positive is a negative. So your answer is -16.5. Estimate. So when we did division, we said, listen, we're not going to make you do calculation. We're not going to make you do long division, but we are going to make you have to look at that question and rationalize the answer based on your knowledge of money. So we said, take this first one as how much money you have, and the second one is what size pile you are making. So for this one, I'm going to interpret, I have $8, and I'm dividing it into piles of 50 cents. If I have $8 and I have to make piles that are 50 cents high, I can make 16 piles. So therefore, the answer is approximately 16. If I take my calculator just to show you, and actually do 8.159 divided by 0.483, my estimation of 16 is pretty good, 16.89. And that's how you estimate divisions. In the next one, same idea. This time it's a different idea, but same practice. I have 20 cents, and I have to divide it into piles of $1. If I have 20 cents and I have to make a pile of $1, let's pretend this is a pile of $1. This is $1 high. 20 cents is only a fifth of a pile, right? A fifth of a pile. So therefore, my answer would be a fifth, but a positive divided by a negative is a negative. So as a fraction, it's a -5th, or since we started as a decimal, -0.2, because 1/5 is equal to 2/10, which is equal to 2/10. Your next question is your fraction rational numbers. It says 1/8 take away 3/5. So the process is identical to what you learned at grade 7. There is no difference. The only difference is when you go to add or subtract your numerators, you have to do a little bit of thinking. In this case, first thing is, of course, to find a common denominator. I'll use 40. Next thing is to make equivalent fractions, right? So I multiply by 5, or is it multiplied by 8, multiplied by 8, multiplied by 5, multiplied by 5, made my equivalent fractions. And I told you that at this particular point, you have to keep your denominator and subtract your numerators. So I need to see this step. And for those of you who aren't showing it still, I don't know what more to tell you. 5 take away 4 is 1. 5 take away 5 is 0. 5 take away 6 is -1. 5 take away 24 is -19. So therefore, 1/8 take away 3/5 is -19/40. That's lowest terms. The next question, you have a mixed fraction that you're adding. The only difference is change this to improper. Now you find your common denominator of 15. This is multiplied by 3, so we'll get negative 18 fifteenths plus 40 fifteenths. Negative 18 plus 40, add your numerators, keep your denominator. I have more positives than negatives. How many more? I have 22 more positives than I do negatives. So your answer is positive 22 fifteenths, or 1 and 7 fifteenths. The next question is a slight bit difficult because it has 3 terms. But since they're adding and subtracting, we know we need common denominators here. So 4, 5, and 20. I'm going to use the denominator of 20, and I'm going to make all 3 fractions have denominators of 20. This is going to be 15 twentieths plus negative 4 twentieths. Take away 19 twentieths. I'm going to add them and subtract them. And then what I'm going to do is I'm going to write this out as a denominator of 20. 15 plus negative 4, take away a positive 19. Well, 15 plus a negative 4 is 11. And 11 take away 19 is negative 8. So your answer is negative 8 twentieths, which in lowest terms is negative 2 fifths. Now the good news for grade 9 students is multiplication and division of fractions seems like it should be harder, but it's actually easier. And when you multiply 2 fractions together, back in grade 8, you learned about this idea of cross reduction. Okay? And if I think about this, I'm going to explain just real quick what cross reduction means, just to refresh your memory. When I multiply fractions, I multiply the numerators, and I multiply the denominators. Now, it does not matter how I get 84, negative 84. I could either multiply 4 by 21, or alternatively, I could swap these two, put a 21 here and a negative 4 there. But if I did that, I knew that that's not going to affect the product of my answer. Either way, if I swap those two numbers, I still end up with negative 84. But if I did end up with negative 84, and I did swap those numerators, we could see that if I take that out there, I could have had this question instead. This question here and this question here are going to yield the same answer. No matter what I do, those 2 fraction multiplications are going to be the same. And if I think of it this way, instead, I don't have to start with 21 over 7 because 21 over 7 is really 3 over 1 in lowest terms. And negative 4 over 22 is actually negative 2 over 11 instead. So I could have multiplied 3 over 1 multiplied by negative 2 over 11 instead of this or instead of that. And I still would have gotten the same answer. So by swapping the numerators, let's see if I can go back here. Oh, you son of a goat. There. By swapping the numerators, I end up with something that I can cross-reduce. But rather than actually physically write it out, what we do instead is we look across and do that cross-reduction. So 21 over 7 is 3 over 1, just like if I had done this here, 3 over 1. And negative 4 over 22 is negative 2 over 11, which would have been the same thing I did here. And now I multiply my numerators. Negative 2 times 3 is going to be negative 6. 1 times 11 is going to be 11. And my answer to this question is negative 6/11. Now, if you didn't cross-reduce, and you simply multiplied your numerators and multiplied your denominators, you get negative 84 over 140, 154. And you had to reduce this by dividing by 2 until you got down to negative 6 over 11. So in my opinion, reducing this down to lowest terms is very complicated, but doing cross reduction makes your life a whole lot easier. The next question is a mixed fraction divided by a whole number. 1 2/3 is 5/3 divided by. Now we know when we divide by a negative 5, what we actually want to do is keep the first fraction, change the multiplication, and use the reciprocal of the second. Since the second is a fraction, it's a whole number, we can consider a whole number to be this, and therefore its reciprocal would be negative 1 over 5. Look for cross reduction if you can, because now we're multiplying, and multiplying is the only time you can do cross reduction. 5 over 5 will give me a 1 over 1. So when I multiply the numerators, 1 times negative 1, 1 times negative 1 over 3 times 1 will be negative 1 over 3 is your answer. If you didn't cross reduce, you got negative 5 over 15, and then you reduced by dividing by 5. Either way, you still ended up with negative 1/3. Next question. Estimate using a number line. What is the square root of 15? So what we're supposed to do here is we're supposed to put perfect squares that we do know on both sides of this. So the square root of 16 is the first perfect square after 15 that I know, and the square root of 9 is the first perfect square before the square root of 16 that we know that's a whole number. So the square root of 15, based on the number line alone, would be somewhere about there. And if I erase all this stuff, now that I've used it as my parameters, and say what number is this, I would say the square root of 15 is approximately 3.8 or 3.9. Okay, it's approximately 3.8 or 3.9. I have no idea because I'm not allowed to use a calculator. If I take my calculator and cheat right now, square root of 15, where's my square root button gone? He's gone. Oh, there it is there. It's 3.9. I was off. The next one, what is the square root of 0.08? Well, the square root of 0.09 is the same thing as the square root of 9 hundredths, which if I think about what fraction times itself is 9 hundredths, is 3/10. So the square root of 9 hundredths is 3/10. And the square root of 4 hundredths is 2/10. So therefore the square root of 8 hundredths would be right around there. So therefore the square root of 8 hundredths is approximately 0.29, 0.28, 0.28. I'll take my calculator just to see. Bring it over here. Square root of 8 hundredths, square root button. It's approximately 0.28. Hey, I got it. Look at that. Perfect. All based on that number line. Okay. Anyway, hopefully we were talking about tattoos in the video, but if we were, it is a weird tattoo to get. So since numbers that are perfect square have one number that multiplied by themselves to get that number, the question for this is, what fraction multiplied by itself can give you 81 over 121? So if your numerator and your denominator are perfect squares, then the fraction itself, or the rational number in fraction form, is a perfect square. So that's going to be 9 over 9, 11 over 11. So therefore, the square root of 81 over 121 is going to be equal to 9/11. Okay, so it is a perfect square. B, if I can bring it down here. Now, because it's a mixed fraction, you were told you can't do this process if it's a mixed fraction. You must change it to improper. So 25 times 1 is 25 plus is 36 over 25 as an improper fraction. And what fraction multiplied by itself will give you that? 6 times 6 is 5 times 5. So therefore, the square root of 1 and 11/25 is equal to 6/5 or 1 1/5. It is a perfect square as well. Now for questions C and D, you're not given the fraction form, you're given the decimal form. And what you were told to do if it's in decimal form is change the decimal into a fraction. So 0.4 is actually 4/10. And if I say what fraction multiplied by itself is 4/10, well, the numerator works out well because 4 is a perfect square. But the problem is 10 is not a perfect square. So therefore, decimal 4 is not a perfect square, and we can see that because if I take decimal 4 and press the square root button, it gives me a non-terminating, non-repeating decimal. Conversely, If I take decimal 0.04, right, which is 4 over 100, that is a perfect square. And if I square root that, I get a terminating decimal as a square root. And the last one, 16 thousandths, 0 decimal tenths, hundredths, thousandths. So 16 thousandths, is that a perfect square? What fraction times itself? Well, 4 works, so the numerator works. But there is no number that multiplies by itself to get 1,000. 10 times 10 is 100, and 100 times 100 is 10,000, not 1,000. So NAPS, not a perfect square. Conversely, if I go back to decimals 1/6 and press square root, that is a perfect square. And decimal 0016, which is 16 ten-thousandths, that is a perfect square. But 16 thousandths, if I square root that, it is not a perfect square. That's the end of it.